Chapter 7, Section 3 is trigonometric equations, specifically solving trig equations. This first problem says, determine if theta equals pi over 4 is a solution to an equation. Well, how do we determine if something is a solution? You can solve it. The first method would be to solve it. The second method would be to plug in. So if I have a value that they've given me, let's plug that in for theta in the equation. In other words, I'm going to write 2 sine of pi over 4, because I've plugged in for theta, plus root 2 equals 0. Now, if this makes a true statement, then this is a solution to the problem. If it doesn't make the statement true, then this is not a solution. Well, what is the sine of pi over 4? Think about your unit circle, and the sine value of pi over 4 is really root 2 over 2. So sine of pi over 4 can be replaced with root 2 over 2. That's multiplied by 2, add root 2, and see if that equals 0. This cancels, root 2 plus root 2. Oh, that doesn't equal 0 because you have a positive plus a positive. That is not going to work. So the answer to the question is whether it's a solution is no. But think about what would make this solution work. Think about what would make this equation work. What if our final thing right here had been negative root 2 plus 2? Where on the unit circle could we have found negative root 2 over 2 for a sine value? Look at your unit circle, find 2 locations where negative root 2 over 2 exists. And you'll find that 5 pi over 4 is one of them. What's another? Where sine is negative, 7 pi over 4. And let's just prove one of them. Let's do 2 sine of 5 pi over 4 plus root 2. 5 sine of 5 pi over 4 is negative root 2 over 2 times 2. This cancels. Negative root 2 plus root 2 is 0, and that does work. But are those the only solutions in the world that would make this statement true? Are those the only solutions that would make this equation true? And the answer is there are others. These are not the only 2. They do both make it true. But what else would? Think about what else would have the same sine value as 5 pi over 4. What else would have the same sine value as 7 pi over 4? Wouldn't every coterminal angle also give me the same sine value? So the general solution of what would make this equation true would be 5 pi over 4 plus its coterminals, every single one of them, and 7 pi over 4 plus its coterminals, every single one of them. So when k is an integer. That's called the general solution to an equation, when you list every equation answer that could possibly ever be. How do we know they're wanting a general solution? Well, first of all, they'll tell us, write the general equation, or they'll just say solve. In this problem, I want every single answer that makes this equation true. So let's solve. Let's put 2 cosine of theta minus root 3 equals 0. Let's add root 3 to both sides. 2 cosine of theta equals root 3. Divide by 2. Cosine of theta equals root 3 over 2. So think about your, root 3 over 2. Think about your unit circle. How many places is the cosine of theta going to be root 3 over 2? In other words, where is the inverse cosine of root 3 over 2? Well, we know on the unit circle that that's going to happen in quadrants 1 and 4. Cosine is positive. This is positive root 3 over 2 in 2 different places. So theta can equal, let's see, root 3 over 2, that's the longer width, so that's pi over 6, Or theta could equal 11 pi over 6. In addition, every coterminal of those angles, every coterminal where k is an integer, would be a solution to that problem. So theta is equal to pi over 6 plus its coterminals, and 11 pi over 6 plus its coterminals. So let's take a look at this next problem. How is this problem different? This problem is different in a couple of ways. First of all, they don't want every answer in the whole wide world. They only want the answers between 0 and 2 pi. Well, what that means to me is they only want the solutions one time around a site, one time around the circle. But here's a problem. In this equation, 2 cosine of 2 theta minus 1, when I solve, let's go ahead and do that, 2 cosine of 2 theta minus 1 equals 0. So 2 cosine of 2 theta equals 1. Cosine of 2 theta equals 1/2. When we do the inverse cosine, we're not finding theta. We're finding 2 theta. Now 2 theta would exist as 1/2, a cosine value of 1/2 in two locations. Pi over 3 and all of its coterminals, and 2 theta would exist at 5 pi over 3 plus all of its coterminals. We haven't solved for theta yet. My answer is, what would theta be? And think about the graph of this, 2 cosine of 2 theta minus 1. Isn't the period now one single pi? Well, let's look at how we can prove that. What would happen if I divided 2 theta and pi over 3 and 2 pi k? What would happen if I divide the whole problem by 2? Wouldn't we have theta equals pi over 6 plus a single pi k? That's the new period, pi over 6 plus pi k. This one would be theta equals 5 pi over 6 plus pi k. Well, when you look at that, pi k is adding 6/6. 1 pi over 6 plus 6/6. My answers would be pi over 6 and 7 pi over 6. I would also have 5 pi over 6 and 1 pi later, 11 pi over 6. So these are the answers. There's 4 answers to my equation. Let's take a look at that from a different standpoint. Let's take a look at that equation from a graphing standpoint. What if I drew, sorry about that, a couple more papers there. What if I drew the equation 2 cosine of 2 theta? Well, when I draw that, my midline is at 0, my maximum is at 2, my minimum is at -2. And I want to know where that equals 1, because once we move the 1 over, that's what we had. The period is equal to pi now. So I'm going to go 1, 2, 3, 4, draw my cosine curve in, and I know that it's going to cross 1 in 2 places, right there. But they asked me to give the domain from 0 all the way to 2 pi. So what I would have to do in this case is extend my graph a whole nother period to take it out to 2 pi. Sorry about that. 1, 2, 3, 4 more tick marks. I'm going to carry this on, and it's going to cross again. It's going to cross 4 times. So you have some choices. You can take a look at it graphically, or you can take a look at it from the general equation. But once you have the general equation, only find the values that would end up between 0 and 2 pi. There's the 4 values that end up between 0 and 2 pi.